Good day, everybody. I wanted to share this problem with you that's similar to an SMO, that stands for Singapore Mathematics Olympiad. I believe it was a junior level problem, but to me it's a hard problem if you take a look at this expression that we're supposed to factor. Now, what's kind of insidious about this problem is that the first part is completely factored, but you have this dangling term here. So you could think of this as a two-termed expression, but the first term is completely factored. But how do we write this entire object as being completely factored? One thing to notice very, very quickly is that if you multiply this first factor right here by 5, you get something fairly close. You see how we have a 5 here and a 10 here? We have a 5 here and a 10 here, so it's close. But notice we can make an adjustment here. If we just call this very first guy y, okay, well, the second will just be 5y minus 24, which is kind of cool. Minus 24x, excuse me, okay? And of course, we still have the minus 36x squared here. So you're wondering, well, what kind of progress is that going to be? Okay, what kind of progress is that going to be for us? Well, let's go down and take a look here. I've done a lot of the work for you. This is the part I just wrote down for you. Now, so you can, when you multiply this out, you can see what you end up with right here. When you expand this out, it becomes this. Okay, it becomes this expression. The expression we just went through that's fairly easy to motivate. When we do this, okay, our original equation is going to become exactly this when we expand it all out. See, not much happened here other than we just multiply this out. Okay, but notice that we have a break here because this piece right here has a possibility of factoring. Okay, so if it's going to factor, it would have to look like 5y like this and y. All right. If it's going to factor, it has to be that way. Now, in order to get a minus 24xy, we would have to put minus 6x right here. Okay. And plus 6x right here. So you see, in two variables, we have an expression that is completely factored. Okay. But if you take a look at what was our original substitution? Our original substitution is just this very first term, right? X squared plus 7x plus 2. So if you multiply that by 5 and add 6x, you would get 5x squared. Well, we already know what that's equal to, okay? We have 5x squared plus 35x plus 10, right? Okay. So this would become, let me just write it underneath. This would become 5x squared plus 41x plus 10. And I can't quite keep it on the screen for you guys. Sorry about that, but this is what I got right here. In other words, we already know what 5y is, right? 5y is equal to this expression right here. Okay, but we have to add 6x to it, right? We have to add 6x to it in this factor form, and that gives you 41x. And in a similar fashion, we have to subtract 6x from x squared plus 7x minus 2. And so this part over here would just become x squared plus x plus 2. And I thought this was super cool. It's the only thing I would ever discover on my own. I just was going over this SMO solution manual, and it showed this idea. Because, I mean, in a way, it looks kind of hopeless if you don't do a substitution. So this is done right here. This is completely factored, okay? Completely factored. Okay, I just said completely factored. All right, so it's that's done. We're finished with the problem. So again, to me, it's amazing. You look at this, and you go, what? What you could do maybe is expand it all out, and you would get a 4th degree polynomial. But then maybe you could do factoring by grouping from that point of view. But we all know that that's kind of tough, really. I don't know if there's any, I guess there's algorithms that do that, but this noticing this substitution is very, very crucial. In other words, I never wrote it down up here, but we did, this was y equals to 5, y is equal to x squared plus 7x plus 2, right? And because it was almost, see, it was almost what we needed. It was almost what we needed. We got the 5 and the 10, but we didn't have the 11, so that's why we had to add the, well, we got 55 right here, and we had to subtract off to get the 11 back, right? So that's what made it work, actually. So, and then we managed to factor this expression in 2 variables, then substitute y back in, is how that works. So, anyway, that's it, folks. I'm just double checking, make sure I got it right. This looks correct. The quantity 5x squared plus 41x plus 10 times the quantity x squared plus x plus 2. Okay, that's all. Thanks for viewing.